Let's take next question. The correct statement regarding interstitial compounds is they have higher melting point than the pure metal. In case of interstitial compound, some small sized atoms or the molecules get into the interstitial side and they increases the melting point of that metal. It means they have higher melting point than the pure metal. It is correct statement. They are chemically reactive. This is an incorrect statement because generally these interstitial compounds are chemically inert. Further, they are typical ionic compound. If we talk about interstitial compounds, it's not necessary. They are not typically ionic compound. Further, they are stoichiometric compound. No, these are non-stoichiometric compound because certain substances get fixed in the interstitial site of the compound and their stoichiometry get disturbed. That's why this is also incorrect. So which statement is correct? Only one statement, and that's given here in option 1. So I'm just choosing it as the correct one. After that, question number 72. The purest form of iron is, if we talk about the purest form of iron, that is wrought iron. It's a common question that you should know, and we are choosing it as the correct one. Question number 73. The iron having spin magnetic moment 5.92 bm, Bohr magneton, is, if we talk about the spin magnetic moment, that is calculated by the simple formula that mu is equals to root n plus 2. What is n here? This n is the number of unpaired electrons. Its unit is bm, that's Bohr magneton. Now, we have different species given here, and if you consider these species, you have to just find out the number of unpaired electrons in the given species. If I talk about the first species, that is Cr2 positive. If we talk about this species, in this case, the atomic number of chromium is 24. We know that. It means in case of Cr2 positive, there are total 22 electrons and the configuration becomes 3d4. The unpaired electrons are 4 in this case. Further, if we talk about this Mn2 positive, in this case, the configuration is 3d5. Unpaired electrons are 5 here. In case of Fe2 positive, in this case, the configuration is 3d6. Again, the unpaired electrons are 4. And in case of Ni2 positive, there is the configuration that is 3d8. How many unpaired electrons are there? In this case, there are 3 unpaired electrons. And we have the unpaired electrons given here. By placing the value of unpaired electron in this formula, you can find out the spin magnetic moment for this case and you can compare this with the given value. On the basis of that, you can find out the correct answer. So if I place here the n value as 5 for Mn2 positive, I'll find it that this value is equal to root 35 and the value of root 35 is approximately 5.92 pm. While for other number of unpaired electron, it is not equal. That's why this Mn2 plus is the correct answer for this particular question. So I'm just choosing it as the correct one. Now, after this, question number 74. Nessler's reagent is quite interesting question. It is based on the simple Nessler's reagent and its formula is K2HgI4. It is the alkaline K2HgI4 and that's why I'll choose it as the correct option. Option 1. Question number 75. The metal which cannot form amalgam is, we have learnt about different type of amalgam. Basically, amalgam are the alloy with mercury. So, if I talk about zinc, sodium, iron and gold, these are given in the options. Which one is not forming amalgam with mercury? Correct answer is iron. Iron cannot form amalgam and we can choose option 3 as the correct answer for this particular question. Now,